Hello, everyone, and welcome to the 8th episode of the Wolfram Student Podcast. I'm Sam, your host. This is the Wolfram Student Podcast, where every fortnight we dive into a new innovative project done by high schoolers using the Wolfram language. For our 8th episode, let's welcome Niccolo Monti, who will be discussing his project on building a way to discover relationships between websites by the visual content unsupervised and supervised. Hello, Niccolo.
Hello, Sam.
Yeah, thank you for coming. You want to quickly tell us a little bit about yourself?
Sure. As you said, my name is Nicolo. I'm currently enrolled in the second year of scientific school, and I'm 15.
Cool. Yeah. So I guess where are you from?
I'm from Pescara, Italy.
Oh, so you attended the Wolfram summer camp. Well, I'm assuming you attended the 2022 one, so you did it virtually.
Yeah.
Well, I guess it was mostly entirely virtually, but a bit further than most people in the States. Do you want to tell us a little bit about your experience at camp?
I really enjoyed it a lot. I the camp was a great experience to me to work on something which was quite new. I never done this sort of I work a lot with computer vision and stuff, but I really had no opportunity to work on this kind of specific problem. And I found that camp was a really great experience to deep dive in this specific problem. I learned a lot and I had a lot of fun.
Yeah, I'm glad you had a great experience there. And then just to wrap this up, it's a question we ask everyone. But what's your favorite Wolfram function?
I'd say probably dissolve because it's crazy powerful, and I basically use it for everything now. I like modeling stuff a lot with it.
Yeah, okay, cool. We've heard a lot of different functions, so it's nice to hear yours as well. So let's get started with your project. So can you give us a quick summary of your project?
Sure. Basically, it's possible to understand the relation between websites from their textual content. But the question here was, can we just do it by looking at the images? So, in other words, we have two websites, well, a bunch of websites, and we want to understand if we can find a way to understand, for example, communities of websites, or for example, extracting features about those websites to understand how they relate to each other.
Cool. So I guess how did you were there specific methods that you used to find this relationship?
Sure. So the first thing that I've done was basically taking a bunch of companies. In this case, I got those. I have mostly taken companies. I've tried to take them from different sectors. What I've done is I proceeded with scrapping them. So I created like this is, for example, one page depth for the Nestle website. I have first created a graph about the website to understand that's a graph of the pages, and for each pages I proceeded to download all the images associated to a website. Then what I've done is if we want to understand the relation between images, we don't have just to look at colors, at similar colors, because we would lose a lot of information. What I've done in this project is that I've tried to look at to compare images by their content instead of their appearance. Obviously, appearance is like mostly it's also taken out in consideration, but more on the side of shapes of object rather than the pure colors. What I use is I use this concept, which used a lot in image style transfer, which is basically perceptual distance. what I'm doing is I'm not comparing images in a pixel space. So the first pixel is similar to the second pixel, etc. I am taking a backbone neural network, which has been trained on a task, in this case, classification, but that's not mandatory. For example, very recently, self-supervised learning models are gaining a lot of traction. In this case, I used ResNet as a backbone. So what I do is, as you can see from the formula, this here is basically is a feature map. So I am basically taking an image, running through the network, not until the end where there is like the cross probabilities, but I'm taking up to a certain depth so that I get the activation map of the convolutional layers, which means that by measuring the distance of those activation maps, I can identify features. So here.
Sorry. Well, I had a few questions about what you're talking about. So up in the web crawling, what exact that graph that you had that looked pretty cool? What exactly does the graph represent?
Sure. So basically, this is the center page. This is the home page. This is the like here nestle.com, and those other nodes are basically like if you go on a website, click on a direct link to another page, that could be one of those nodes. So they're basically the web pages directly related to the first. If we are like to run, for example, up to depth 2, what would happen is that almost each of those nodes would have a connection to other nodes, which would be links to other pages from the page.
Oh, I see. And then you visited each one of these pages and got the images and compiled them.
Exactly.
Okay, cool. And then second of all, your image analysis. So I just want to make sure I understand this right. So, so what you first did is you put them through like a neural network.
Exactly.
And you use this concept called perceptual distance to find like how exactly these images were related. Can you explain a bit about how you made this neural network and then like what role perceptual distance plays?
Sure. So this neural network is ResNet, taken from the, as you can see from the model from the Wolfram neural network repository, which has been pre-trained on classifying images. For example, you give it a picture of a bird, and the node which is associated with the class bird should have a high probability. And what it does is it learns to associate pattern of pixels to quote-unquote concepts. This means that two similar things will activate similar part of the neural network, even though they might, for example, be on different colors or in different positions. And since they would activate a different part of the neural network, even though, for example, we have, I don't know, a black cat and a white cat, the images will be very similar because the part of the neural network which let's say associated to cat, we cannot control this association, but possibility, let's say associated to cat, will get activated. So even though we have completely different pixels, we can understand there is a cat in the image. And then what we do here with perceptual distance is, if you look closely at the formula, you see two sums, which are basically for the x and y activation map. And here you can see minus, square, and mean, because this is basically a mean squared error if you look closely to it. And so what we do is, okay, we calculate the mean squared error at the position as the feature map x, y between image x and image y if you are comparing two images. Alright, so that was how the neural network extracts data from the images.
Cool. So then once you had the data extracted from the images, what did you do after that?
So the first analysis that I do is I try, given a website, so a single website, understand how the content of this website relates to each other. Um, and basically build a new, nearest neighbor graph. And we can see that the graph of images breaks down into very clearly into communities. If we zoom up, we can see that, for example, picture of landscapes are very close. Those are all landscapes. Even though, look at these colors, then look at those colors, and those colors. They are very different, but they're basically a picture of a landscape. So they are very close, in the graph. And same thing here. There are people. Those are different colors, different poses, but people are still grouped together. Same thing for logos of the same, similar logos. You can see that all those logos are very close to each other. So that's the first thing that we do to understand.
That's really cool. I just want to say that because like normally I think just the colors would have separated it and made it difficult, but this is really amazing.
And okay, so the next step is to understand how does a website relate to others given their content, because it's cool to understand at the inside of a website, but since we already know that a website is related to itself, it's a bit useless. So what we do is the first cool thing that we do is we need to first look at the images in the latent space. So in other words, what we did before is we learned a latent representation of the images. Well, we didn't learn. We use a pretend network, but you got the idea. So basically, what was the goal? The goal was to take a picture and compress it to a lower dimensional manifold, a lower dimensional space, where images with similar content but different colors would be close together. Well, maybe images with similar colors but different content would be far together. So an image is turned into a vector, and what we do is by applying dimensionality reduction to this vector, we can plot it in this case on a 2D space. So each of these dots is an image, and which is projected down to this space. Obviously, we use a bigger space for example, this uses bigger dimensionality data, and so we can see that, for example, we can see how for example, here we can see that a lot of companies have very similar images because we can see each color is a different company, and we can see that there are a lot of different companies very close together. This means that those companies have it's like a contact point, similar images. In this case, we can see that, for example, blue is Nestle and purple is Blitz. We can see that Nestle and Blitz have got some overlapping, and so the idea what is we find the clusters in here. We find where cluster of image, and then for each cluster we try to understand, okay, what percentage of this cluster is from company A, what percentage of this cluster is from company B, and so we can understand the ties. We do it here. For example, here this is correlation graph filtered by correlation score. Sorry, we can see here the correlation score greater or equal to 0 means that obviously every company is related to all the others. It's not useful. But as we increase the score, we can start filter connection which are greater or equal to a threshold that we give it, and we can see how the connection between websites evolve as we demand for more correlation. And we can discover that Blitz and Nestle surprisingly publish some similar images on their on their website.
So I see. So you're saying like initially, if you don't focus on correlation at all, pretty much every company is like tied with each other. But as you increase it a bit, then you get to see like how certain companies tend to have stronger relationships with others, and then like ultimately you see that it's Blith and Nestle that have like the deepest or most similar connection. What exactly? I've never heard of Blith, so do you know exactly what it does? So I'm kind of curious what compares with Nestle.
To be honest, I just looked for a list of random companies on Google and put it. So that time I went on their website, it was at camp, so I may be wrong, but if I don't remember wrong, it should be a construction company.
Huh.
And I think
that's kind of weird because like
because, sorry.
no, because like, well, if Blith is more like construction and Nestle is more like drinks, I think, and like food.
If I don't go wrong, I checked out because it also seems strange to me. But they've got a lot of like images of person together and landscapes, both Nestle and Blitz, which means that like probably the program sees that both Blitz and Nestle put a lot of like images of landscape, so they must be tied. And so I was, it was a bit strange. There are obviously connections that make sense here, but I think that this wasn't like useful enough because it's okay to understand whether companies are tied, like they have similar content, but the question was actually, can we understand something about the website just from looking at the images, and can we understand the correlation also between the image and what the company does?
Yeah, that makes sense. Okay, cool. So what did you?
Sorry.
Sorry, yeah. What did you do, I guess, to determine that last part of your project?
So yeah, so far, I've been focusing on doing stuff completely unsupervised, which we can we can discover useful relation. But if we, for example, want to use this thing to, for example, understand a certain thing on an unseen website, that's clearly not enough. So what I said to do is I took those companies and I assigned them, each of them, a score. This could be either doing binary or a regression, so you're not like, you can even put 0.23 or anything. You're not bound to like use 0 or 1. So for each company, I say, okay, is Nestle a tech company? No. Is Glencore tech company? No. Is Cargill a tech company? No. Is Microsoft a tech company? Yes, 1. I say that target is equal to 1. So for example, here I could, put I would have like to, I could, for example, use geographical position, and in target use like a specific geographical position. For example, I could put here where the companies have their HQ, and here I could, put the geographical position of Germany as target. For example, to understand whether a company, for example, may be based in Germany, if their images are in this way, for example, and if they employ a specific graphic style, for example, characteristic. But in this case, I use tech company or not as a question, as the question we want to answer. So what I do is I take, if you remember here, we have those representation for websites, for images. So we've got image, company which is associated to that image, and the latent representation. So what I do is actually to learn for each of the factor how close the company is to the target, And what I basically can pull out of this is you can think of those as like x and y coordinates of the latent space, of the projected down latent space, and you can think as this here at the as the score. So we can see that we can identify regions in where like image with latent space is in that specific region tend to separate a lot from like low scores and tend to have high scores. And so here we can learn that we could also like, you can think this as like a 3D graph. Actually, the original one was like a 3D plot, but it was too noisy. So I decided to keep it this way, but you can also learn a distribution on this. And averaging the average prediction, we can give it to unseen companies. In this case, Dell, which is economic computer, and Lindt, which makes chocolate. And we can see that Lindt has a lot of images which are low scores and which are not related to tech, and have basically 0 images which are related to tech. And we can see that that Dell has got like, obviously they've got images which are not related to tech. For example, like, I don't know, buttons or I don't know, picture of people. But they've also got a fair amount of pictures which are related and pictures which are mildly related. And so from here we can identify that 2 different we can identify what's an unseen feature, a feature from a handful of training websites, and we can discover information about the website.
Oh, okay. So I see. So if you go back up to that graph, you had the 3D one. Yeah. So I see. So like if you looked at it from above, I suppose, just that 2D is like the representation of the images and their connections. But like if you visualize the score level with it as well, then you can like see the ones on the top are like the tech companies and the ones on the bottom aren't. Okay. Okay, that's pretty cool. My question was about the neural network you used when you were like when you were testing unseen companies.
Oh, that one, sorry.
Yeah. Yeah, in that neural network, like I guess how exactly did you determine a score from that? Did you like take each image from there and then like run like an image analysis on it and then take like what was that score? How was that score like precisely determined?
Exactly that. So if we need to go back on this one. Okay, this one is basically each image plotted on a lower dimensional latent space. So we can see like each color, as you know, as I said, is a company, each color. And if you remember, we know, for example, whether a certain company belongs to a class or has a certain score. So what we do is we ask the model to predict, given this image, can you predict the features about the website that we gave you? So this means that features which are highly related to the stuff we are trying to predict will be selected, and the one we're not want. So basically, if this is for example, we take all the images in the Dell website, and for each image we ask the model to predict the score that we gave it. No, sorry, not that, because that is like testing company. For each images in the Nestle, we ask it to predict, for example, 0. For each image in IBM, we ask it to predict 1, and so on.
Oh, I see. So you like used like your pre-made data on what companies were tech companies to train images from unseen companies. Oh, okay. Okay. Yeah, thank you. That's really cool to see.
Thank you.
Um, so I guess if that wraps up your project, um, yeah, it was really cool to see the way you chose to like connect this idea because originally when I thought comparing images, I was confused like how exactly you would be able to do that, but you created something really amazing. So that was nice to see. Um, I guess like of this entire project, what was your favorite part to code?
So I really liked working on this graph, uh, mostly because the result was very like cool to see, cool to observe, and to explore, and so it gave me a burst of satisfaction when I saw it.
Yeah, that's definitely a good factor. And then what was probably the most difficult part for you to code in this?
Oh, that's an easy question. This part, it seems easy, but it gave me so much debug errors, so much error while coding. You can't even imagine.
Yeah. I think the Wolfram language has like a capacity to make things that like in Python or Java would be like massive functions and like write them in a single line in the Wolfram language. But this one is still looks pretty complicated.
Yeah, I could have split out this in many function, but for some reason I really love making like very big one line function like this one, one line increment, this one. I don't know what. It's probably a bad habit that I should get rid about it. But when we have when we have, as you know, code in the same line, especially in the Wolfram language, it becomes quite hard to debug. So it would probably have been easier if I split up into many parts so that I could easily identify the error, because here I wasn't sure what the error was while debugging.
True, but I think I remember like when I was at camp that a mentor told me that if I ended up writing like a function that was more than like 10 lines long, then I was using the Wolfram language wrong. So I think you've done a great job. Um, but yeah, uh, so I guess like now that you've finished this, do you plan to like take it on in the future, or is there anything specific you want to do now that you finished this?
Something that I would like to try is, I compare website at the current different website at the current time. Something which would be cool to do, which actually people at camp, mentors such as me, is to understand the relation of the same website, the same snapshot of a website, but in different part of time, like going on the web archive, downloading, for example, a website each year, and understand how the style of the website evolved into the span of time, in that span of time, by running the same exact method on those images, historical images.
Huh. Yeah, that seems really interesting. Cool. Um, yeah, I wish you good luck in trying to complete that one day. Um, yeah. And just to wrap it up, now that you've like completed an entire project with the Wolfram language, um, like I guess how have you enjoyed using it? Is it something you think you'll like do more projects in? Um, is Python or Java? I don't know what language if you've coded in any before, but are those still more appealing, or just what are your final thoughts about just Wolfram as a whole now that you've used it?
To be honest, I've been like a huge Mathematica fan for years, even before coming at camp. So Mathematica the Wolfram language was already my programming language of choice. So I
Oh,
basically do everything in Mathematica. Yeah.
oh, okay, that's cool. Um, yeah, uh, I think that was pretty much almost everything. Thank you so much for coming on, Nicolo, and sharing your project with us. It was amazing to see.
Thank you for having me on the podcast.
Yeah. I wish you good luck in everything you do with Wolfram language in the future. And hopefully we get to see some amazing projects from you soon.
Thank you.
Thanks for listening to this episode of the Wolfram Student Podcast. We hope you learned something new and took away insights from today's discussion. If you want to be featured in a future episode, fill out the form at tinyurl.com/wsp-interest-form.
And be sure to tune back in 2 weeks' time to hear our next episode. Once again, thanks for listening to this episode of the Wolfram Student Podcast.